In this video, we discuss remaining assumptions for or less model. And the fourth assumption is about homoscedasticity, or constant variance of the stochastic term, or residual, or the error term. Okay, so very informally, variance is the measure of discrepancy. In finance, it's frequently accepted measure of risk, like how actual values of variable deviate from the predicted or average values of the variable. Of course, there are very formal statistical tests for indicating whether this assumption is fulfilled or not, but we can also elaborate on some informal visual analysis. So this is regression line. Those are empirical values of Gini, and the distance between them stands for error term or residual, as you wish. So as you can see, when the value of GDP per capita is relatively small, this distance is relatively big. So there is huge dispersion, both above and below the regression line. However, when value of GDP per capita increases, this dispersion actually decreases. So this variance becomes smaller. So we have big distances when GDP per capita is small, and relatively short distances when the value of GDP per capita is relatively high. Of course, it's not enough to make an explicit assumption regarding whether variance is constant or not, but it's already enough to indicate some problems about this model. So the dispersion is big, and then it becomes smaller, and it actually indicates that variance is not constant. The fifth assumption is about the absence of autocorrelation between the disturbance term. So UI and UJ stand for residuals for different observations. Let's say this distance is UI and this distance is UJ. And hypothetically, if this condition is fulfilled, there shall be no correlation between the disturbance terms. Autocorrelation problem is more relevant for estimations based on time series and panel data. We will discuss this a bit later. What might be the reasons for autocorrelation and how to deal with it. And in order to give you some idea about autocorrelation, we will also use some basic visual analysis. So you already have residuals, and you have to add the lag of this variable. So lag is basically just observation in period 1 minus 1. Sorry, t minus 1, previous one. So we will do the very same thing. We will add residual as dependent variable. And the first lag as the independent variable. And this is the output. You also have it here. So as you can see, there is a very strong dependency between residual and the value of residual in the previous period. In other words, we are dealing with autocorrelation in this model, which means that this assumption is not fulfilled and model is not actually good. It's not reliable. It's not designed in a proper way. And finally, the sixth assumption is relatively easy. It says that the number of observations shall be greater than the number of parameters to be estimated. So for instance, if you have 30 observations in your Excel spreadsheet, in your data set, you shall not include more than 29 variables. Of course, this is an exaggeration. You will rarely be able to even think about such a big number of potential variables, but nevertheless, this is assumption to be fulfilled. By the way, good news for you is that if you try to estimate the model, program will fail to do this, and you will get an error message. Like analogously to the first assumption, it's very difficult to mess up with the sixth assumption. So actually that was it. Now you know everything about properly designed OLS model in theory. During the next lectures, we will discuss how you test formally whether those assumptions are fulfilled and how you fix the problems related to those assumptions. And yeah, so that was it, and thank you for your attention.